Now we are looking at the division of modular arithmetic. Division of modular arithmetic. Let's look at the example. 2 divided by 3 should be in mode 4. So now let's try to do this. We are having 2 divided by 3. So we know 2 divided by 3 gives us a certain number. Let's use x to represent the number. So 2 divided by 3, we now use x to represent the value it wants to give us. We want to do it in mode 4. Now, and you realize that if you multiply 3 times x, it should be able to give us this 2 back. If you multiply this 3 times x, it should give us this 2 back. So you can say 3 times x is same thing as 2. Now, you realize that normally when we get here, what we needed to do is to divide both sides by 3 to be able to get the value for x. But the problem we have here is that whenever we divide in modular arithmetic, we are not interested in decimals or fraction. So if you say we divide this both sides by 3, so it remains x here. But if we divide 2 by 3, it's going to give us a fraction or decimal. So because of that, since this is written in mode 4, we will continue to add 4 till anytime we divide this x by 3, it will give us that whole number. So since this is, we have 2 here already, it's in mode 4, let's add 4, we have 6. So if we now say 6 divided by 3 will give us 2. So that means it's okay like that. So divide both sides by 3. So we are left with what? X here. So 2 plus 4 is 6, right? So 6 divided by 3 is what? 2. So we added 4 so that until we'll be adding the 4 because it's in mode 4, until the time we get we divide it by the divisor to give us an whole number before we stop. So that means this is 6 divided by 3 is what? 2. So that x is equal to 2 in mode 4. Now let's have another example. 8 divided by 2 to be in mode 3. So we can say 8 divided by 2 is equal to x. So you know we want to do it in mode. We want to do this in mode 3. Now, you know that we can easily say that this 2 times x should be equal to 8. 2 times x is equal to what? This 8. So when we multiply 2 times this x should give us this 8. So since we want to do it in mode 3, so the coefficient of, divide both sides by the coefficient of x, that's 2. Realize if we divide this 8 by 2, it will give us remainder. So we don't need to add any value. So that means we have 2 into here is what? X. 8 divided by 2 is what? 4. Now you realize the question said wants us. The question wants us to do it in mode 3. Now this 4 is more than 3. Let's reduce it to mode 3. How many 3 are in 4? 1, remainder 1. So that means our remainder will now be the solution. So that means x is equal to 1 in mode 3. Another example. If we have 65 divided by 5, we want it to be done in mode 4. So 65 divided by 5, if we divide this 5 by 5, let's say the value we want to get is x. So we want this to be done in mode 4. To be done in mode 4. Now, we realize that when you multiply 5 by this x, it should give us 65. 5 times x should give us this 65. So since if we divide it both sides by 5, you are like if you divide 65 by 5 to give us whole number. So that means we divide it that way. 5 and 5 cancel 5 and remaining x here. 65 divided by 5 will give us 13. We want to write it in mode 4. 13 is more than 4. So how many 4 are in 13? We have 3, remainder 1. So now that means the remainder will now be the solution. The answer is what? X is equal to 1. So that is now written in mode 4. X equals 1. Now let's look at another example. We are having 92 divided by 10. 92 divided by 10 to be in mode 4. Now we want to do this in mode 4. So we can say 92 divided by 10 is what? X. Now if it is x, we can easily say 10 times x should be equal to 92. 10 times x should be equal to 92. Now we need to divide both sides by 10 here. But if we divide 92 by 10, we are going to get 9 point something. And in modular arithmetic, we work with whole numbers. So what we do, since this is in mode 4, we will add 4 to 92. If you add 4 to 92, that is 96. If you divide 96 by 10, it will still give you decimal. Add another 4, making it what? 100. So if you divide 100 by 10, it will now give you whole number. So that's when you now divide both sides by 10. So if you divide this by 10, you are left with x here. 100 divided by 10 is what? 10. Now since it should be in mode 4, how many 4 can you see in 10? We have 2. Remainder 2. So the remainder will now be the solution. So x should be equal to 2. That is written in mode 4. Now let's look at this. Solve the following equations. So now 2x is equal to 3 in mode 7. We have to solve 2x is equal to 3 in mode 7. Similar to what we have done. So, we ought to divide both sides by 2. But if we divide this 3 by 2, it's going to give us a decimal. Because of that, we are going to add, since it is in mode 7, let's add 7 to this 3. So 3 times 7 is what? 10. If you divide 10 by 2, it will now give you a number. So that's when you now divide both sides by 2. So that means you have 2x divided by 2 should be equal to 10 over 2. 2x divided by 2 is what? 2x. Then 10 divided by 2 is 5. We want this to be in mode 7. So already since this is not up to 7, so that means that will be the solution. Let's have another example. We are having 4x should be equal to 6 to be written in mode 9. Now to be written in mode 9, look at this. We are having 4x. If you divide both sides by 4 straight, 6 divided by 4 will give you a decimal. So because of that, and since this is in mode 9, you are going to add 9 to it. So 6 plus 9 is what? 15. If you divide 15 by 4, it will still give you a decimal. We add another 9. So making 6 plus 9 plus 9, which will be 24. If you divide 24 by 4, it will give you a whole number. So that means you can have it divide both sides by 4. When you divide both sides by 4, so here you have an x should be equal to 24 divided by 4 will give us 6. That is in mode 9. Let's have another example. So we are having c 2x plus 3 equals 1. We want this to be done in mode 6. So that is, first of all, let's bring this plus 3 to this side. It will turn to what? Minus 3. 2x is equal to 1 minus 3. 1 minus 3 will give us what? Minus 2. So you're having 2x is equal to minus 2. But if you divide both sides by 2, you realize that this one will give us a negative value. We don't want a negative value in modular arithmetic. Because of that, since this is in mode 6, add 6 to this. So that means minus 2 plus 6 will give us what? 4. So now, because we now have 4 can be divided by 2 to give us whole number. So you divide both sides by 2. So you are left with x here. Should be equal to 4 divided by 2 is 2. That is in mode 6. Now, lastly, Let's have the last example. We are having 5x plus 2 should be equal to 3 in mode 11. So you realize this is plus 2 here. When plus crosses equality sign, it will turn to minus. So you have minus 2. So 5x is equal to 3 minus 2. 3 minus 2 will give us 1. But if you now divide, if you say you want to divide 5x both side by 5, 1 over 5 is a fraction or decimal. So because of that, since this is 11, if you add 11 to it, you're having 12. 12 also, if you divide it by 5, it will give you a decimal. Add 12 again, add 11 again, making 23. If you add 11, making 23. 23 also divided by 5 will give you decimal. Again, add 11, making 34. If you add 11, making 34, it will still give you a decimal when divided by 5. Add 11 again, making 45. So 45 divided by 5 will give you whole number. So that means you now have your x to be equal to 45 divided by 5 is 9. So this is in mode 11. So for the work practice, number 1, find the values in the module written beside them. 29 divided by 3 in module 11. B. 42 divided by 11 in module 2. C. 34 divided by 5 in mode 7. D. 20 divided by 8 in mode 10. E. 17 divided by 9 in mode 2. F. 92 divided by 10 in mode 4. Number 2. Solve the following equations in the given module. A. 5x should be equal to 2 in mode 7. B. 8 plus x is equal to 0 in mode 9. C. m minus 4 is equal to 0 in mode 6. D. 5x plus 2 is equal to 4 in mode 6. Make sure you like, subscribe and comment. Thank you.